Foundations of Math 2, Unit 3, simplifying radicals. So we've already done simplifying radicals. We are going to expand that to some cube roots and some operations with radicals. So first of all, I'm going to start with this. Anytime there's a negative under a square root, so negative under an even root, so that is square to the fourth, to the sixth, whatever the number is here. Remember, if there's not a number, it's an understood 2. Negative under an even root, it gives you a non-real answer. You will get into that more in Math 2. We're not going to worry about that right now. We're just starting with non-real answer. So we have a negative here, so we know that this one is going to be a non-real answer. Just like before when we simplified our radicals, if it's not a perfect square factor, then if it's not a perfect square, then you need to find a perfect square factor. So my perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, yada, yada, yada. And then we'll do the cubes in a minute. My perfect square, so 48 is not on that list. I'm going to list my factors of 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12. No, the 5 doesn't go in it. 6 and 8, 7 doesn't go in it. My greatest perfect square factor is 16. If you had chosen 4, it is not completely simplified. You have to use 16. So this is equivalent to the square root of 16 times the square root of 3. The square root of 16, well, 16 is equal to 4 squared. The square root squareds cancel, and you have 4 root 3. The next one is the square root of 128, so I'm listing my factors of 128. If you don't know how to list your factors, what you can do is you can go on your calculator and put your radicand, the number underneath, over x, and look at your table. You're only looking at the whole numbers, and you want to go down your y column to find your first perfect square. My first perfect square there is 64. I can keep going down here and list all my factors. So I have 1 and 128, 2 and 64, 3 doesn't go in, 4 and 32, 8 and 16, and it looks like that's about it. 16 and 8 is the next one. So my biggest perfect square there is 64. Square root of 128 is the same as the square root of 64 times the square root of 2. 64 is 8 squared. Square root squareds cancel, and you have 8 root 2. Now when you have cube roots, you're looking for perfect cubes. My perfect cubes, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. 3 is 27. 4 is 64. 5 is 125, and it does keep going. So if this is not on my perfect cubes, I want to list my factors and find the biggest perfect cube factor, because this is a cubed root. The index matters. It makes a big difference in your answer. So I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. My biggest perfect cube is 8. So this is equal to the cube root of 8 times the cube root of 2. The cubed root of 8, so that 8 is equal to 2 cubed times the cube root of 2. The cube root cube cancels, and you have 2 cube roots of 2. When you have an even index here, so an odd index, an odd root, the negative just gets carried out to the front. So this is equivalent to negative cube root of 27, because when you have a negative times a negative times a negative, it's still negative, because 2 negatives makes a positive, positive and a negative makes it a negative again. So now 27 is a perfect cube, so that is equal to 3 cubed, cube root cube cancels, and you have negative 3. 128, so I'm listing my factors of 128 again. I've already got them listed. I'm just rewriting those. So now my biggest perfect cube, 64, is on both lists. So that's still my biggest perfect cube. So I have the cubed root of 64 times the cubed root of 2. But the cubed root of 64 is equal to 4 cubed, 8 squared and 4 cubed. The cubed root cube cancels, so I have 4 times the cubed root of 2. Now when we're dealing with variables, our exponents are different for cube roots. So we're doing the same thing that we used to do. Splitting it up, we have the square root of 54 times the square root of x to the 5th times the square root of y to the 8th times the square root of z. Factors of 54, 1 and 54. 2 and 27. 3 and 18. 6 and 9. My biggest perfect square factor is 6 and 9. So this splits up into the square root of 9 times the square root of 6. 9 is equal to 3 squared. The square root squareds cancel, so I have 3 root 6. X to the 5th, remember you're going to divide your exponent by 2 by your index. Remember it's an understood 2. So 5 is not divisible by 2, so I need to split it up. X to the 4th root x. Divide your exponent by 2. So you have x squared root x. 8 is divisible by 2, so that's y to the 8 over 2, which is y to the 4th. And z to the first power, that is less than 2, so that guy just stays. We just bring him down. We have the square root of z. Then you're just rewriting your answer. Everything that's outside of the radical goes together, and everything that's underneath the radical goes together. So you have 3x squared y to the 4th times the square root of 6xz. Number 2, splitting this up, the square root of 24 times the square root of x squared times the square root of y to the 9th. 24 is not a perfect square, so I'm going to list my factors. 1 and 24, 2 and 12, 3 and 8, 4 and 6. My biggest perfect square factor is 4, so I'm splitting it up into the square root of 4 and the square root of 6. 4 is 2 squared. The square root squareds cancel, and you have 2 square root of 6. 2 is divisible by our index of 2, so we just say x to the 2 over 2, which is the same thing as x to the first, or x. 9 is not divisible by 2, so we split it up, y to the 8th and y. Divide our exponent by our index of 2, which is y to the 4th, root y. And then rewrite our answer. You have 2x y to the 4th, square root of 6y. With our cube roots, it's a little different. So we're going to do our numbers the same way we just did them. The negative can just be brought out front with a cubed root. So now we have the cubed root of 16 times the cubed root of a to the 7th times the cubed root of b to the 10th. So now 16, I'm going to list my factors, 1 and 16, 2 and 8, 4 and 4. 16 is a perfect square, but it is not a perfect cube. 8 is the biggest perfect cube factor. This number makes a big difference. So I'm going to split this up. I still have that negative out front into the cube root of 8 times the cube root of 2. 8 is equal to 2 cubed. The cube root cube cancels, and you have negative 2 cube root of 2. Now, with the square root, we took our exponents and we divided them by 2 because that was our understood index. So now our exponent needs to be divisible by 3. 7 is not divisible by 3, but 6 is. So I'm going to take 1 away. I have a to the 6th, the cube root of a. Take my power over my root. So I have a squared cube root of a. b to the 10th. 10 is not divisible by 3, so I can take 1 away and make 9. 9 is divisible by 3. So now I have b to the 9 over 3 times the cubed root of b, or b cubed times the cubed root of b. Do the same thing as with the square root. Write everything that's outside together and everything that's inside together. The last one, the cube root of 48, x to the 8th, y to the 12th. So 48 is not a perfect cube. So I need to list my factors of 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. The only perfect cube on that list is 8. So I'm splitting it up. I have the cubed root of 8 times the cubed root of 6. 8 is equal to 2 cubed. Cube root cube cancels, and I have 2 times the cube root of 6. 8 is not divisible by 3. 7 is not divisible by 3. But 6 is divisible by 3. So I'm rewriting this as x to the 6th. If I have x to the 6th, to get x to the 8th, I need to have x squared. 2 is less than 3, so this is as simplified as it gets. It does not get any better than that. Right here, rewrite it as a power over root. So I have x squared, cubed root of x squared. Y to the 12th is divisible by 3, so I have 12 over 3, which is y to the 4th. And then just rewrite my answer. 2x squared, y to the 4th, cubed root of 6x squared. Rationalizing the denominator, that means to get the square root out of the denominator. Simplest form and proper form is not having a square root in the denominator. We're only going to work with square roots on this one. So to undo the square root, you have to square it. So what I'm going to do to square it is multiply both the top and the bottom by the square root of 6. Whatever you do to the bottom, you have to do to the top. So what I get is 5 root 6 on the top. When you multiply fractions, you multiply straight across. And the square root of 6 times 6 on the bottom. Well, 6 times 6 is 36. The square root of 36 is 6. 36 is equal to 6 squared. Square root squareds cancel. You have 5 root 6 over 6. You can check these in your calculator. You cannot do it in your calculator, but you can check it in your calculator. 5 divided by the square root of 6. That's my number for my first one. Check my second one. 5 times the square root of 6 divided by 6. It should give you the same number. When you have something like this, you're going to look for the conjugate. You have to multiply by the conjugate. So if you have a plus b times the square root of c, the conjugate is a minus b times the square root of c. You're going to change the sign of your radical. So here, I'm going to multiply the top and the bottom by 1 minus 2 root 5. When you do that, you have to FOIL out the denominator. So on top, I'm distributing my 7. I have 7 minus 14 root 5. And on the bottom, I'm FOILing it out. So I have 1 times 1, which is 1. 1 times negative 2 root 5 is negative 2 root 5. Positive 2 root 5 times 1 is positive 2 root 5. And positive 2 root 5 minus 2 root 5 is negative 2 root 5 squared. We have a positive and a negative. So now this cancels. So we have 7 minus 14 root 5 on top. And 1 minus, when you raise a product to a power, you distribute. So you have 2 squared times the square root of 5 squared. Two squared is 4. Square root of 5 squared, that cancels. so times 5. Order of operations, you have to do that multiplication first. So you have 1 minus 20, which is negative 19. So 7 minus 14 root 5 over negative 19. On the back, when you multiply radicals, you just multiply what's underneath it and then simplify. So this is equivalent to the square root of 8x cubed times 18x. 8 times 18 is 144. Multiply like bases, add exponents. 3 plus 1 is x to the 4th. And then I'm just simplifying. The square root of 144 times the square root of x to the 4th. 144 is equal to 12 squared. Those cancel and you get 12. Power over root, x to the 4 over 2, x squared. So you have 12x squared. When you add or subtract, you have to have the same radicand. So it's like having like terms with a variable. You have to have the same thing underneath the radical. So first I'm going to simplify these radicals. So 18 is not as simplified as it goes. I need to list my factors of 18. 1 and 18, 2 and 9, 3 and 6. My biggest perfect square is 9. So I have 4 times the square root of 9 times the square root of 2. Well, 9 is 3 squared. Square root squareds cancel. I have 4 times 3 root 2, which is 12 root 2. 50 is not a perfect square, but it does have a perfect square factor. 1 and 50, 2 and 25, 5 and 10. My biggest perfect square factor is 25. I still have that 2 out front. So I have 2 times the square root of 25 times the square root of 2. 25 is equal to 5 squared, or 5 times 5. Square root squares cancel, so I have 2 times 5 times the square root of 2, which is 10 square roots of 2. So if when you simplify you don't get the same thing under the radical, you can't simplify this at all. Right here, now that I have the same thing, I just operate on what's outside. It's like having 12x plus 10x, only this time our x is the square root of 2. 12 plus 10 is 22, so I have 22 square roots of 2. And then the last one, I need to start with simplifying my radicals. 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8, 3 and 16. 16 is my biggest perfect square factor. I have the square root of 16 times the square root of 3. 16 is 4 squared. Square root squareds cancel. I have 4 root 3. 27, 1 and 27, 3 and 9. 9 is my biggest perfect square factor. I still have my minus 6 out front. I have the square root of 9 times the square root of 3. 9 is 3 squared. Square root squared cancels. And now I can simplify this. Negative 6 times 3 is negative 18. Bring down my other first one. And then the last one is 12. 1 and 12, 2 and 6, 3 and 4. 4 is my biggest perfect square factor. I still have my plus 4 out front. And then I have the square root of 4 times the square root of 3. 4 is equal to 2 squared. Square root squareds cancel. 4 times 2 root 3, which is 8 root 3. Since all of these have a root 3, I can say 4 minus 18 plus 8. 4 minus 18 plus 8 is negative 6. Sorry. So I have negative 6 square roots of 3.